Pascal's principle, and then Archimedes. Alright, so one of the things that we should be able to answer today is the regular Coke, when placed in water, is going to remain at the bottom. Diet Coke is going to float to the surface. You know, both of them are 12 ounces, right? Given the fact that both of them are 12 ounces, also given the fact that they have the same volume, why then the Diet Coke is the one that floats to the surface, as the regular Coke remains at the bottom? And most of you guys said Diet Coke must be less dense. My question is, if they have the same mass, same weight, and same volume, how could it be that the Diet Coke is less dense? How does that even make sense? Alright, so Pascal's principle is the one that we were just now.
A modern airliner is a device with 1 million parts that pushes fragile humans to the edge of space and the edge of the sound barrier. The failure of one or two of those parts at precisely the right moment, and the whole magnificent system falls to earth, often killing hundreds.
One of the co-pilots came rushing back several times, back and forth. And you could look at the eyes of the stewardess and know we were in serious trouble. Just look at their eyes.
Mary and Jim Call did what few people have done. They survived an airline disaster. Theirs came aboard one of the troubled early McDonnell Douglas DC-10s on a 1989 flight to Chicago. Everything seemed perfectly routine until a loud bang rocked the plane. Soon the pilot made an announcement.
After we did the big dive and we heard the big boom, he told us that we lost the tail engine. We really weren't aware that there was a big gaping hole in the back of the plane.
He said he wasn't going to kid us. It was going to be rough, very rough. He said he wasn't going to kid us.
What Jim and Mary didn't know was that the number 2 engine in the tail had lost a fan disc. In an instant, the disintegrating fan's shrapnel punctured all 3 of the plane's redundant hydraulic lines, causing all the hydraulic fluid to leak out, and at the same time chopped off a piece of the tail. With no hydraulics.
Alright, so hydraulics is leaking. That hydraulics means no brakes. No hydraulics means that you're not going to be able to land. No hydraulics means no control. Without the hydraulics, you cannot control any of the surfaces of the airplane.
And had no control of the aircraft. Other aircraft use a 4th separate line in case of accidents like this. At least one passenger knew exactly what was happening. He built commercial airliners for a living.
I recognized some of the noises the aircraft was making. The hydraulic systems were sucking air. I just thought we're dead. No hydraulics, no control.
That's horrible, guys. The last thing to be on an airplane like this is to be an engineer or a physicist, because you know exactly what's going on. Under these circumstances, ignorance is bliss.
No wing surfaces, no brakes.
There's no way to control this airplane.
No nothing.
Yeah, nothing.
For over 40 unforgettable minutes, this DC-10 carrying Bill Mackin and the Calls hurtled through the sky. It almost turned over at least 3 times.
It's gliding. It's a glider.
Passengers watched in horror as the crew dumped excess fuel in preparation for a crash. Surprisingly, there was little panic on board.
Some crying, some people cried, some people prayed.
No, there wasn't hysterics. There was some silent sobbing, people saying the Lord's Prayer, but not the mass hysteria that you would expect.
There was not hysteria at all. People were very, very calm.
Looking at each other.
A TV crew was standing by. Through an incredible piece of flying by the captain, the huge wide body controlled only by the 2 outboard engines miraculously made it to the Sioux City airport. It came to earth only yards short of the runway.
We were
doesn't have brakes,
just like being
so it's friction.
tossed like rag dolls every which way. I got knocked up, and I saw the flames shoot over top of my the left side of the cabin.
All the overhead bins opened up, everything come flying out through the cabin, and we saw the fire and fireball coming down the first class section, and I could feel the heat and see the fire, but I never did get burned. It never got to me.
Incredibly, 185 people, including Bill Mackin, the calls, and the captain, walked away from this fiery disaster. Sadly, 111 weren't so lucky. Captain, the huge wide body could...
Nearly half the people survived thanks to the pilot. How did the pilot control the airplane without the hydraulics? Any ideas? He had no hydraulics. He was not able to control any of the surfaces, yet he was able to control the airplane. What did he do in order to control the airplane? What do you guys think?
He was ripping the e-brake and going into a drift.
He was doing what?
Ripping the e-brake and going into a drift.
All right, what's the only thing he was able to control, guys? Just engines, right?
Yeah, just the
He
engine.
would just throttle up one engine and then throttle up the other one, and he was able to line it up. I'm actually really impressed with the pilot. He was able to line it up with the runway eventually, so that's really, really good piloting. So, hydraulics. How does the magic of hydraulics work? Guys, hydraulics is a force multiplier, and the way it works is it works based upon something called the Pascal's principle. According to the Pascal's principle, if you actually apply a little bit of force here on the left hand side, notice that you have, this is the amount of force being applied to this opening. This is the area that you're looking at, the piston. The output force is going to be magnified. So the input force is going to be F1, F2 is going to be the output force. The output force is going to be larger than the input force. By how much? I want you guys to do a comparison. Take a look at the area, the first area, area number 1, and look at the size of the area number 2. If the second area is 2 times larger than the first one, the force is going to be 2 times larger. If the second area is 3 times larger than the first area, the force is going to be 3 times larger. If the second area is 10 times larger, force is going to be 10 times larger. If the second area 100 times is larger, force is going to be 100 times larger. So how does the magic work? All right, so according to the Pascal's principle, notice that when you apply a little bit of force on the left hand side, you're going to actually change the pressure within the fluid. This change in pressure inside the fluid is going to get transferred and transmitted all throughout the fluid undiminished. So this is known as the Pascal's principle. So any change in pressure inside the fluid is going to get transmitted all throughout the fluid undiminished. So which means that the final pressure is only going to depend on the depth. So let's just illustrate that concept. So Pascal's principle, final pressure is going to depend on the depth. All right. Moving on to the Pascal's principle. All right, so let's have an input piston here, and let's have an output piston located right here. All right, so we got the input force, and we will have the output force located right here. input area, so we will have the output area. So what do we know? Which area is going to experience, which region is going to experience higher pressure? This region or this region? Which one experiences more pressure? PI or PL? What do you guys think? Say again?
It's the same.
It has got to be the same, right? Because the fluid pressure only depends on the depth, so PI and PO will be the same. Given the fact that the pressure is going to be the same, the pressure is constant. In this case, this is going to be constant. What happens? Force divided by area. What happens when you increase the area, size of the area? When you increase the size of the area, the force is going to increase. That's it. So pressures are the same. PI is the same as PL because the pressure only depends on the depth. If that's the case, if you increase the area, and here you're increasing the area, the force is also going to increase. So force is going to increase proportionally with the area. If you want to make the output force 100 times larger, the area needs to be 100 times bigger in comparison to the input area. Alright, so this is known as the Pascal's principle. Alright, so which
What do we put down as the term for Pascal's principle?
Okay. Joseph, repeat.
What are we going to put for the definition of Pascal's principle?
All right, the definition of the Pascal principle is on the left, which means that any change in pressure is going to get transmitted all throughout the fluid undiminished. So, for example, if this is your car's brake system, you apply a little bit of a force on the brake system, on the brake pedal. So, which means that you increase the pressure inside the fluid, right? That increase in pressure is going to get transmitted out throughout the brake fluid undiminished, all the way up to the brake mechanism. So that's known as the Pascal's principle. The pressures will be identical at identical heights, so the force depends on the area of the output piston. If the area of the output piston is bigger than the area of the input piston, the force is going to be larger. So that's the definition. So by using the Pascal's principle, you can't actually lift a car up by applying a very little amount of force.